Hello, welcome to Flipped. So today we are talking about the molar volume of gases, and it's easier to express the amount of gases in volume instead of mass, because to get the mass of a substance, we have to actually exert some force on the reader, like the weighing scale or something. But we know that gas, we cannot do that to a gas, so it's actually easier to measure its volume instead. And by this Avogadro's law, this is a person's name, okay, he came up with this law, that's why it's named after him, okay. What he says is that equal number of gas molecules, regardless of what kind they are, occupy the same volume, assuming same temperature and pressure. What do I mean? So I have two spheres here, okay, there's two volumes of a bubble maybe, okay, they are equal volume. So I have these blue molecules here, okay, maybe there are 4 of them, and there are 4 green molecules here, okay. What he's saying is that, okay, assuming that these both spheres have the same volume, there will be the same number of particles in them. So in this case, there are 4 in both of them. Okay, this is what Avogadro's law is talking about. And the next one is that 1 mole of gas occupies 24 dm cube of volume, and this is the molar volume of gases. So if there's a 24 dm cube of volume, inside the 24 dm cube, okay, we'll have 1 mole of gases, which is 6 times 10 to the power 23 particles. You don't have to know that in detail, but you just have to know that in 24 dm cube, there exists 1 mole of gas, regardless of what kind of gas they are. So this comes the formula: volume of gas equals to number of moles times 24 dm cube. Okay, I've drawn this triangle for you, as I have in the mass chapter. Okay, mass, recall. Previously it was mass on top, okay, over mole times mr. Okay, so this is a variance. This is a volume over mole, volume over 24 dm cube. Okay, so from this formula, we can also change it into this one. This is actually more commonly used. Number of moles, okay, this is n, okay, equals to volume divided 24. So I just shifted this 24 dm cube over here. Okay, you can use the triangle to determine this as well, because number of moles, when I want moles, I just cancel out, cover the mole. I can see that it's volume over 24. Okay, if I want volume, I can just cover the volume. I can see that it's mole times 24, okay, as per this equation here. Okay, let's go to some calculations to demonstrate what it actually means. So in this question, I want to calculate the volume occupied by 30 grams of iodine when it sublimes. Okay, sublimes is a recap, is when solid changes to gas directly, it skips the liquid phase. And this one, okay, is a note to tell you that number of moles will not change during a change of state. Okay, so when solid goes to liquid, goes to gas, etc., number of moles will not change. Okay, assume there's no evaporation, etc. Okay, so first we have to find out the relative molecular mass of iodine. Okay, so we know it's mr of iodine is I2, right? Because it's group 7. Okay, is equals to 127. Okay, each of I atom is 127, the mass, but there's 2 of them, so I have to times 2. This one gives me 254. Okay, because it's called a relative molecular mass, relative, okay, there's no units for this. Okay, it's just like this. Okay, and then the number of moles of I2. Okay, we are very familiar with this, right? We know it's from our great triangle. On top here is mass in grams. This is mole. This is mr. Okay, so I want moles, so I just cover this up, and I can see that it's grams over mr. So my gram here is 30 grams over my mr. I just calculated 254. This one gives me, okay, calculator, 0.118 mole to 3SF. Okay, so I know my number of moles will not change, so I can immediately apply to my next triangle, which is this one. Okay, this one is volume, this one is also mole, and this is 24 dm cube. Okay, I can now find the volume of my iodine, I2. Volume of iodine, I2, is actually, cover this volume up to find out it's actually mole times 24. So it's 0.118 mole multiplied by 24 dm cube, giving me 2.83 dm cube. Okay, and this is the answer to this question, okay, to find a volume occupied by 30 grams of iodine when it changes from solid to gas directly. Okay, so the important thing to take note is that number of moles will not change. Okay, this is a very important concept in a lot of questions. Okay, finally, let's just talk about something very quickly. It's called a stoichiometry of gas reactions. Basically, we know that the volume of gas is proportionate to number of moles, right? Basically, volume, okay, is really just mole times 24, okay? But we can usually skip this step because this is a multiplication. We can actually ignore this multiple if we apply this one throughout the gas phase. What do I mean? Okay, it's because when we can skip calculation, directly compare the gas using the ratio. This shortcut, okay, is only applicable if all the reactants are in gaseous phase. Because, so in this case, we have CH4 in oxygen. Basically, this methane gas is burning in oxygen to give us carbon dioxide and water. So 10 cm cube of CH4 will react with 20 cm cube, okay, to give 10 cm cube of CO2 and 20 cm cube of H2O. Why? Because the ratio here is 1 is to 2 is to 1 is to 2. Okay, basically, this is what we're talking about. We are skipping the calculation of volume. Skipping the calculation of moles just to get to the volume, okay, because based on the ratio. But the only prerequisite is that all of them have to be in gas phase. Okay, and this is the this will close the molar volume of gases and the stoichiometry of gas reactions.